See where else? Maybe I'll sit. Not move around so much. There we go. My name's Tom Patterson. I am the very newly minted Managing Director for Emerging Technology Security at Accenture. For those of you that know me, they'll know that that's new, brand new in my case. But the subject matter is near and dear to my heart. And that's the same subject matter that we put this panel together to discuss: emerging technology security. These new emerging technologies are going to change the way we compute. They're going to change the way we decision. They're going to change the way we communicate. It's all going to be different by the end of this decade. In all of our lifetimes, in all of our work lifetimes, it's all going to change. And so everything we've been working on so far, all of our thinking about how we secure systems, has to also change. In some cases, it has to evolve. In other cases, it has to disrupt. I appreciate the flyover. But in all cases, we, the security practitioners, need to be the ones leading change. So I've spent the good part of my career in security, initially kinetic, but mostly of late cyber. And I've focused on all aspects. The last 5 or 6 years have been focused on national policy around emerging technology security. And each of these areas that we're going to be talking about today have its own set of imperatives, its own set of issues, its own set of opportunities, and its own set of experts. So with that, I'm going to introduce this esteemed panel to talk about emerging technology securities for the next hour, for the rest of this hour. And I hope that you will all think of some questions you want to ask the panel at the end of this, because we want to truly make this as interactive as possible. So let me start, Daniel, with you. If you would just give a brief introduction of yourself. Daniel is working in a fascinating area today, which is helping to protect neighborhoods and regions around the world. And his history is even broader, working on the Fourth Industrial Revolution. So Daniel, just a quick introduction, if you would.
Thanks very much, Tom. What a great pleasure to be here. Daniel Karamy. I have been following the issues, policies, technology, business models around emerging threats and our responses to them for the past 2 decades. I think for the first, in the beginning, it was with the UN. Then I went as the markets were crashing in October 2008. I switched to the World Economic Forum. I still remember a lot of people questioning those decisions, but then it was the best decision I took. With the World Economic Forum, we opened up a center on cybersecurity, created a few groups on quantum computing, AI, and then the last job there that I had was the network of centers for the Fourth Industrial Revolution. Now I'm working mainly around issues of urban security, intersection with cybersecurity.
And you're going to talk to us today, the focus today, you're going to focus on which of the new emerging techs?
I think I will reserve majority of my remarks on AI, but I will also touch a little bit of quantum and how it connects, because I think the future of general artificial intelligence could be merged with quantum technologies.
It's almost as though we planned that transaction there. So with the word quantum, I have to have my good fortune to introduce Dr. John Gouda Shelby. And John is going to focus his discussion today on quantum, the quantum opportunities, the quantum threats, and what to do about it. And I suspect, because of your background, you'll be bringing a lot of your former jobs focus to this current job. So if you wouldn't mind, John, introducing yourself to everyone.
Okay.
John has no trouble projecting.
So, John Selby, if you meet me, you can call me Gouda, that's fine. I had a long career in the Marine Corps, When I retired, I went into work for the MITRE Corporation. Then I worked for Raytheon, and now I work for Q-Secure. I started out in this world. My first encryption problem was simply talking on a network. The network consisted of a radio and a bunch of people who were listening in or talking on the radio. Then I moved into digital interoperability and then stayed in that world for a long time. And then we decided that we needed to secure that, went into the cybersecurity world or managed things in the cybersecurity world. And now we find that I'm back in encryption, this time in post-quantum. So my background is an attack helicopter pilot. I was a test pilot, a program manager, and I'm a systems engineer by trade and very operationally focused as opposed to deep technical focus.
Thank you, John. And the anchor desk down there, we have Dr. Roberto Sandoval. And Roberto, you're going to talk to us about 5G, which I'm told is more than just faster than 4G, but there's some other nuance to it. So if you would just introduce yourself, Roberto, to the audience.
Thank you, Tom. My name is Roberto Sandoval. I'm from San Antonio. I worked for the Air Force for over 30 years in the intel community. My last assignment was working for the Air Force DCGS program, which is the Predator program. We were primarily focused on information assurance, certification, and accreditation of the systems, which are in support of the Predator comms worldwide with also countries of partnership in the Five Eyes arena. And I've also supported Space ComSec, several classified programs that really opened my eyes about communications and security. And one of my other assignments was with the leading the OSD cybersecurity red team for ACTD, Advanced Concept Technology Demonstrations. And currently I'm tasked in supporting an OSD program for the 5G rollout to include and focus on the 5G core functions.
Excellent. So what you've just heard is going to be the basis for our talk today. Now, there are a lot of emerging technologies. There's some additional ones that are represented here in the beautiful tech port here in San Antonio, Texas. And that we're not diminishing their relevance to the future. These three, however, we believe are going to fundamentally change the way we do business going forward. They are not just additive to the way we do it or just sequentially more faster, better, stronger. They are different. And that's why we decided to focus. The last 5 years, I had the opportunity to work with the White House on a program called the National Cyber Moonshot, where we dove deep into a way to answer the president's question of, can we make the internet safe and secure for critical infrastructure by the end of this coming decade, by the end of the 2020s? And the answer, it turns out, is yes. Even though many of you have been around, like I have, through this first incarnation of the internet, which was designed to be open, which was designed to let anybody do anything at any time, anywhere. So how can you possibly secure that? Well, the way we know we now can is because these disruptive technologies that are coming are so new that we have a second chance, a second bite at the apple to try and, when we design them, when we implement them, when we use them, to use them in a safer and more secure, a privacy-centric way so that we can really improve life for everyone on the planet. And these opportunities are not to be sneezed at. They're not something that any of us take lightly. There's a lot of work that's been going on. There's a lot more to do. And we want everyone here to really understand why we do what we do and what these issues are. So we're going to walk through in a three-part overview of emerging tech. Why, what, and how. So the why is why we care, why we're doing all this. And so, for quantum, why do we care about quantum computing? Isn't it just faster? Why do we care about 5G? Does that mean we can just download our Netflix a little bit faster? And isn't AI good? It'll steer our cars for us. That's terrific. What could possibly go wrong in any of those scenarios? So if I could ask you three just to talk to us in your individual area a little bit about why we should all care about the security aspects. And Dana, let me start with you. And why should we care about the security aspects of artificial intelligence?
Right. Well, I don't think that if there would be people that do not care about this issue, they would not be here, right? But to start with. But think about it. Just Deloitte published their fifth State of AI in the Enterprise report just a few days ago, and they highlighted the growing discrepancy between the deployment of AI and ML systems in enterprises and actually successful pilots or successful deployment. So all the executives that they interviewed and surveyed, more than 2,600, said, yes, AI is important, and yes, we're putting huge money towards it. Yes, we're deploying perhaps 5 pilots or more. And yet all of them said the uptake is wrong, or there's something that didn't go according to the plan. There was no buy-in either at the top or at the bottom. So there was something that is going wrong. So that's an importance of it, of course. But then there are a couple of issues that I think I would like to highlight and zoom in specifically on the cyber aspect of AI deployments. And thus, I was inspired by the previous panel on healthcare. And if you think about, cyber systems as your own body, your broken leg is the result of a brute force attack. Your cold or your other diseases is a response to different viruses and different other vulnerabilities. Now, AI vulnerability is quite a different type of vulnerability because essentially it's not breaking by brute force normally, or it's just doing something that you ask it to do in a way that you didn't intend it to do it. So it's more like a cancer. So it hijacks the same mechanism of cell reproduction and just does it better and faster for what reason you don't know. So it's a very different type of vulnerability. So that was issue number one. The second issue, I think, as we're talking about the cybersecurity supply chain holistically, shifting left, shifting right, on all that, we increasingly need to think about in terms of hardware, software. But we also need humanware, of course, but we need to start thinking about the underlying data sets. You can actually quite easily poison the AI by actually introducing something in the data sets. And if the people that train these machine learning systems, and if you think about it, machine learning systems is exactly what the value of them is, that they're constantly learning, right? They're what they are learning, that's a different question. If you think about it, my previous life, I was working
The virus is something that sort of keeps mutating and taking over. I think that's something that we can all use to communicate when we talk about AI security. I also love that you brought up poisoning the data, training data is a critical issue. And you mentioned poisoning. We also see unintentional biases being brought into those data sets so that you get unintentional outcomes. Regardless of how well. Appreciate that, Dan. Roberta, let me jump down to you and 5G and ask you if you give us, the audience, an overview on why should everyone be really focused on the security issues around 5G in today's world?
5G is introducing a lot of new capabilities that will enhance artificial use of bandwidth. That will also introduce function non-emotional latency for critical systems. For example, people autonomous vehicles or perhaps some that have remote or
Well, hold on.
Capabilities that deal with specific types of beamwidth and towers that are physically have to be located because of that millimeter wave and the degradation of those links that will be occurring. So they need to be studied, they need to be well understood, but they also need to be conforming to the standards that are being addressed by the organizations worldwide. And then adding to that, we need the DoD security conformance. Again, the risk mitigation frameworks are important. The guidelines that the NIST and CISA are constantly working on and upgrading based on those integration of new technologies. So those areas are being addressed, but not just for, in our case, that we're looking at the core, but they're looking at all those subsystems, the user equipment, the different types of phones, the different types of devices that are going to connect to the 5G network, the different towers that service providers will be using, what kind of agreements those service providers need to adhere to in order to communicate, because now 5G brings in an open system. Now you won't have a service provider that handles only your phone, but with these open system architecture, any service provider will be able to communicate with the 5G network and the devices that are tied into it. So the security features for those devices, for those technologies, is very important. Needs to be well understood. And what we are doing is focusing on the 5G core, the functions that are being introduced by the standalone 5G core system. And what we're looking at is conformance of the security assurances that are being designed into those virtualized network functions. So that's a big challenge. Identifying the right tactics, techniques, and procedures to test those interfaces and to develop tools and techniques that can become a standard throughout DoD and the commercial and industrial areas for, again, the open standards for 5G.
So, there's a lot of life and death in your day job about getting this right for the DoD. Do you see the same kind of care being taken in the rest of the community, in the civilian agencies and in the private sector and internationally?
There is great concern that some of the risk mitigations and security controls that the DoD recommends or requires needs to also be applied or considered in the commercial or industrial world, but also the adherence or conformance to those security assurance specifications that the 3GPP organizations are designing and requiring are applicable as well worldwide and globally. So one of the concerns is having a service provider that your systems may communicate with or connect with, and they're not adhering to those security standards, then there's definitely a threat. So
Excellent.
those policies, security policies, need to be well understood, not only in DoD and government, but also in the commercial world.
Excellent, Roberto. Thank you. Dana, let me turn to you. In AI, you laid out some compelling security issues around, do we trust the data? How are we going to make decisions? What's AI going into? You didn't bring up, but I certainly also care about where AI processing is going to be taking place. Today it's in the cloud. Tomorrow it's going to be in our devices at the edge. Talk to me a little bit about some steps that you're seeing where the industry is moving forward in security to mitigate these risks.
Yes, well, there are a lot of different approaches to these issues. And before I even go into that, one other thing I wanted to mention that I didn't get to mention, one other issue, is that seeing so many young people here, one thing I think very few people are thinking about outside of the corporate IT departments is the cost of all those systems. Do you think that it's only the humans now complaining about the cost of education? I don't think so. I think AI and ML will soon start complaining about what it costs to train those systems as well, which is in ever-increasing data sets and ever-increasing compute necessities now run into millions. A lot of people are now debating, do we bring it back on-prem? Do we keep it in the cloud? And then, of course, there's a question of policies. How do you, is there a benefit of homeschooled AI? Or cloud community college? Is there some sort of Ivy League perhaps model for AI models? So that the issue of cost and affordability to the public, that becomes a huge issue as well. Stanford Human Artificial Intelligence Institute recently also led quite a significant body of work of accessibility of AI, be it foundational models or compute power, and how it should be divided among not only the top universities, but also making available that community colleges and others have access to that. Now, the other thing what I want to say, there's also, I think just like in political world, there's a bit of a polarization. The same is happening in technology world, where there's ever increasing notion and push to further automation and abstraction, anything from low to no code to so on. And at the same time, the SecDevOps are pushing us to move left and give as much power to and transparency as possible. And then perhaps one other final thought I want to mention, and again, this would be a great transition to John here, is that as many of you know, AI is normally pretty good at doing what you're telling it to do and train in one domain. But if you take that AI systems and try to do it in a different domain, even if it's close by, it performs really poorly. And therefore, the recent move by the industry towards quantum-based NLPs and then so on and so forth gives me a great deal of hope that actually perhaps that will move us towards the general purpose of AI in not so distant future.
Really good insight. One of my closing points was going to be to point out how the interconnectivity of all three of these disciplines is an equally important challenge for the world to get right, and you've certainly highlighted that. John, let's ask you. The Financial Times has coined the term "encryptogeddon" to talk about what's going to happen when our adversaries have a cryptographically relevant quantum computer, and all of our secrets will be laid bare. Talk to us about some of the steps that are being taken today to help mitigate that risk.
Well, that's a gargantuan question, certainly.
And you're just the man to handle it.
As always, whenever a new technology emerges, there's a tension between the technology developer and then the counter technology developer. Always a tension. And we're certainly in that period now where the physicists are building quantum computing using all of this spooky stuff in quantum physics, while there are others who are trying to counter that. And it's no different in this data domain that I mentioned before. So I've been around long enough. I guess I'm seasoned, as they say. I've seen a lot of really good ideas come around, and we're usually buried by the magnitude of the problem. So if I look back at digital interoperability, right, that I talked about before, there were a plethora of good ideas on how to solve that problem. All of them suffered under the weight of scale, because you can't simply go out and buy these new things or upgrade an entire Department of Defense, for instance, all at once and make everybody change. There's always going to be a phasing, and that's usually where we fall down. So the question really becomes, if I have, let's call it 20 billion connected devices, how do I make those post-quantum resilient or post-quantum secure and still be able to operate, recognizing that I can't just throw a switch? Well, one of the ways that you do that is you acknowledge that you have to have a mixed fleet, so to speak, that you're going to have pre-quantum and post-quantum operating together. That's a tough problem, but it's a tractable problem. We can solve that problem. Excuse me. One second.
It's a solvable problem, a very smart man once said.
No, I'm glad I brought my coffee up. So the first thing is to honor the threat and understand the lay of the land, understand that there is a problem, and then be able to plan to solve it. So one of the critical things that we have to do is to not reinvent all of our critical infrastructure and lay it on top. So to that end, NIST has helped us out, the National Institute of Standards and Technologies, the government, and the National Security Agency. They have selected the post-quantum algorithms that can be implemented, and they're going to go a long way to help us. We have both wired and wireless systems that both need to be addressed, and you can address those technologies in different ways. But the most important thing is to identify where your, well, I'll call it corporate, whatever the corporate means to you, where your corporate risk is, where those data elements are, where do they reside, where do you need to protect, where do you need to secure your system the most? And then layer in both what I might call line cybersecurity, the vulnerabilities and such, where securing their attack surfaces, and then how do you encrypt the data in case it gets out. So sort of a straightforward problem in terms of concept. In execution, it's a little bit more challenging. One of the other issues that we have, the speaker this morning talked about collaboration within the San Antonio area, which is fantastic. Collaboration is key to solving this problem, and it's partnering with good companies. Tom's a good friend to our company, and we're going to go forward together, I'm sure, in solving the problem, because it's not one-dimensional, it's multidimensional, and the industry's going to have to work together, much like one of the speakers earlier today mentioned. So it's sort of a societal problem, it's a tractable problem. We just have to recognize it and move forward.
Well said, except for the whole coughing, not being able to speak thing. There is really a lot of positive steps that can be taken today. So I'd ask you all, invite you all in the audience that are here in San Antonio, if you have any questions for the panel, you want to get them up to Val has got a mic, just be thinking about them. We're going to do a little lightning round close of what do you recommend? These folks represent the best and the brightest of the security industry. They work for companies that make products. They work for companies that consume products. What are some next steps that you recommend, for the rest of this decade? What should people be focused on in your areas going forward? You start, Daniel.
I think you are already on the right track. You keep learning, you keep going to the events like this, you keep challenging yourself to learn and stay up to date. For me, I'm a very visual guy, and I need to have analogies, and I always try to understand why what I do is important. And perhaps also to your point, Tom, to tie up the three technologies, the three angles, really, we're talking about emerging threats and so on. If you think about it, with the classical compute, we learned how to walk. With the AI/ML, we learned how to run. With 5G, we learned how to drive. When quantum will be around, we need to learn how to swim, how to dive, and how to sail, because it's a completely different domain of operations. But we still have to be able to do our triathlon together.
Roberto, any quick answers?
Well, there's new areas that 5G is considering of incorporating artificial intelligence and machine learning. But these areas are primarily dealing with system performance and controls of those functions within the core. beyond 5G, which is being labeled as 6G, AI and ML will certainly play a strong role in not just in the performance and controls of those systems, but also the security. As the data centers or the information being used by 5G networks moves away from the cloud, away from the internet, and closer to the user in edge computing, what's being researched now is how can we strengthen or secure that edge computing at the edge instead of at the data center. So what that does for you, it localizes any threat vulnerabilities that could potentially harm the network. And it also localizes any other type of artificial intelligence within any other subsystems to include the user equipment, the RAN or the towers, and any other subsystem of the 5G network. So taking AI into consideration and applying it at those different subsystems can help a quicker response for any type of security intrusion and can also localize the threat in those areas.
So you've heard edge from Roberto, you heard edge from Daniel. If you're working at the edge on devices or chips and you're not taking these three technologies into account, you're missing the future. Real quick, John, give us a point or two quickly on quantum next steps.
It's all about the edge.
You missed your joke.
The first step to any resolution is to acknowledge that you have the problem. So from I'll say corporate perspective, what does the industry do? First acknowledge that the problem set exists. Then make an assessment of where your PKI, your public key infrastructure vulnerabilities might lie. Come up with some ideas of where your critical infrastructure specific vulnerabilities lie. I might take that just a step further. Understand where your random numbers come from, for instance, and how the system is actually set up. There's more to that system than meets the eye. And then come up with a strategy to mitigate the risk. What can we do on the technology side is, one, make sure that we're what we'll call algorithm agnostic or algorithm agile, so that we can handle more than one type of encryption, that we can move our encryption along with the threat, because nothing's going to stay static, right? Everything moves, and this is going to move as well as the technology and the countermeasures chase each other. So
I think I appreciate the quick summary. I will say that, at Accenture, I'm very focused on all three of these emerging technology areas. But for those of you that know me, and I see Val over there has known me for a while, and I'm proud of that, know that I'm a very optimistic guy when it comes to the security and the issues that we face. And I don't want to leave this panel with any feeling other than abject optimism. In all three of these areas, there's a lot of really good work going on, a lot everyone can get involved in. In 5G, we saw, if those have been around, if you remember DES, the data encryption standard, we had to move that off of DES globally and onto this new one called Advanced Encryption Standard, or AES. That took a decade. We got to do better this time. We've got to start earlier. We've got to be putting in something that's agile now. A lot of movement in that space, a lot of really good research around AI and what we're doing to weed out unintentional bias, intentional problems, being able to make sure that we have what we want when it goes to the edge and gets locked down. And 5G, this whole movement towards connecting things peer-to-peer, making sure the back office is right. We didn't have a chance to dive into the supply chain issues there, but also big issues. But a lot of really good work going on. I encourage you to stay involved or get involved if you haven't. And I do want to point out that I'm a challenge coin based guy. So I found in my challenge coin rack at home before I left my Alamo chapter of FC, a challenge coin that I probably got 20 years ago, last time I was down here working. So I'm thrilled to be back, and especially in this brand new tech port. Do we have a question over there, Val? Do we have a microphone over there, Val? I can repeat the question if you shout it. I see we have another microphone fast approaching.
Hello, hello. All right. Good afternoon. I'm Robert Franklin. I am a cyber operations major from Augusta University. I had a problem had a question mainly regarding any potential security that they would have. So it's mainly to do with a level of trust. Like, I believe that's a big issue when it comes to cybersecurity. How well do you trust the people around you to do the things that they say they will do for you, as well as the machines that they handle? So I think that's a big thing when it comes to AI too, because that's essentially another human aspect that we have to worry about. So rather than just the humans that we talk to, we also have to worry about the interactions that we have with AI. So with that in mind, how well would you say you trust AI at this point in time? And if you don't, how long would you say it would take for you to be able to trust AI to handle things?
Wow, great question, as I would have expected. Sound system is not set up to communicate that. So it's an AI question. Dan, I'll turn over to you. Let me just grab parts of it that came through. So where are we in AI in its evolution, do you say, from the human aspects of all this? Do we have this right? Or is it still a lot more to be done to make sure that it's really processing the way we want it to process?
Well, let me answer the question with the question: where are we in the human evolution? I mean, we are evolving every day. We're learning, we're adapting, we're changing. The same is with our systems. And I think with the AI, the biggest unanswered question is whether we truly want an artificial intelligence or we want it to an augmented intelligence, and how that would be playing out. So, certainly there's tons of things that needs to be done. There's the big issue, the transparency is a big issue, the black box paradox, of course, which again, many experts are saying that quantum-enabled AI may actually make much more transparent decisions, or because we will be able to see it based on the physics of the decision, or it could make the problem even more difficult to solve.
Way to answer a question that you couldn't hear. All right, with that, let me thank my panelists, Roberto, John, Daniel. I'm Tom Patterson. Thank you very much for thinking of the future.
Thank you all. Thank you, Tom. And this is a great panel. As you can see, the combination of all these three elements led by the leader who has worked on this for a long time. We'll take a quick break as we reassemble the next panel. I know we are lagging one break, but we'll catch up fairly quickly. I know we have a little bit longer evening tonight. We started late, but we have the showcase, innovation showcase will start around 6 o'clock. So, feel free to stretch, relax, and then we'll get the rest of the panels ready. Okay.